Hi there, I'm Professor Casey, and today we're going to do part 1 and part 2 of the lecture on functions and macros. This will be part 1 where we do a quick review of functions and introduce macros. We're going to talk about when you might want to use a macro versus a function and why. And in part 2, we'll talk more about the different types of macros, how to use them, and avoiding some of the common errors we see with them. So we're going to talk about functions and macros. Mostly the differences between them, when we're going to use one versus the other, and the different types of macros. So let's review functions just super quickly. If you remember, functions are always declared via a function prototype. There are no circumstances under which you would not use a function prototype with the style that we teach functions. You should always define the argument types, and you can optionally put the names of those data types inside the function as well in that function prototype. You have to define the return type, even if it's void. Anytime you prototype a function and you don't use it, you don't actually call it, you'll get a warning from your compiler. So when you do write a prototype, it indicates that you need to use it. And prototypes are only required for custom functions. These are functions that you write. For example, if I were to use a math function like sine or cosine, I wouldn't need a function prototype because it's built into a library already. There are two types of functions. We have call by value functions. Remember, this is like copying and pasting the value of a variable from main down to the actual function itself. The current value of a variable gets passed down to the function. It's like it's copied into the local variables of that other function. You can return one thing from a call by value function back to main, but you can't send things back. You can't send multiple things back. It's not like a call by reference function. If you have a data type error, this gets really ugly really quickly. Usually if you're promoting, it's okay. So if I go from an int to a float, you're basically just typecasting something. However, where we start to have issues is if you demote something. So you go from a float to an int or even an int to a char, that starts to get really messy. We also have call by reference functions. If you remember, these are passed by pointers, the addresses, but it means we can change the values of all the references, all the variables from main inside of our function without actually ever copying down those variables. Another review of the function is how it's executed. So at the function call, this will happen in main. Execution for the computer jumps down to the function, does whatever the function says, and then jumps back to that same line. If the function is void at the end, then we don't return anything back to that line that it jumps back to, and it just jumps back into main and starts executing more lines. However, if it's not void, it's going to return a value back to that line. If you remember, we have to actually set that equal to something if we want to use that value later on. So we need to remember to do that, and also remember to set it equal to the right data type. Okay, so let's look at some functions. If I have a void type function called myFunction, and it's expecting two integers called z1 and z2, right? This is my prototype. When I call that function, if I call it with variables a and b, not having previously defined them, right? It's going to send down a and b, but it doesn't know, right? It doesn't know what those variables are. Same thing with z and 2, right? I'm going to send down z to z1, and I'm going to send down 2 to z2. We don't know what z is, though. As long as we're sending these two things and we've set z equal inside of main, then it will send whatever variable is stored in there. We can also send just regular integers, right? 3 and 4 go down to z1 and z2. That works just as well. Inside of functions, you can also use them nested. So we can have a equals a cosine of theta, right? A equals a cosine of theta. We can nest these all in here. These are all built-in functions, but you can do it with custom functions as well. So I have a custom function find k. I've sent it down to alpha. It will do this. It will calculate the power between find k and beta. It can do the log 10. It can multiply all these things. We can do calc z as a custom function. It will do all these things in order, and it will be totally fine doing that. Right? You can even use functions, including custom functions, inside of conditionals. So I can use an if statement or even a while statement with functions built into it. That's totally fine as well. And lastly, I can use functions inside of printfs. So if I want to print out a variable, I can actually call my function as one of these things and it will print back the value. All right, let's talk macros versus functions. So what are macros? Macros are a predefined number written kind of like a variable. And we do this via the define preprocessor directive. So at the very top of your program, you're probably used to seeing the # or hashtag include preprocessor directives. That's where we include the libraries. Right below that, we can also write the # or the hashtag define. And there we can define what macros we want to use. Macros are slightly different than functions because your compiler actually never sees the macro. As your code is gone through, right, when you build it, right before you send it to run, your preprocessor will say, every time I see this word or whatever you have following your define, I'm going to replace it with a number. So your compiler, when you actually execute your code, never sees that it's already replaced. If you've ever used search and replace in Word, it's really, really similar to that. We can make macros actually fairly functional. They can even take arguments. What's different about macros versus functions is that the argument type isn't specified. That means we don't have to specify what data type that goes into it. We can use whatever data type we want, and we can even mix data types. Similarly, for the return type, we don't have to tell it what return type to give. It's just going to do the math and spit out what happens. Macros are generally considered more efficient. However, you can't quite do as many things as you can in functions as in macros, but you can start to replace some very, very simple functions with macros, and it's fairly easy. Let's look at this. So before my preprocessor, right, this is what I have written in my editor in CodeBlocks. I have # define SQ. This is my macro right here. Macros are usually in all caps. And I've told my preprocessor, hey, it takes one argument and that argument's called X. You'll see I just have a space. There's nothing else here. What this is saying is that every time you see SQ, replace X times X with those parentheses. So every time you see XQ, replace X times X. This is going to replace SQ with whatever input it has. So I have my int main, I've declared some variables, whatever, I've printed some stuff out. Now look what I'm printing. I'm printing SQ of Z. Well, Z is 4.0, so what's gonna replace this? It's actually gonna be X times X, or Z times Z. So just before it compiles, right, my preprocessor goes through and it says, oh, every time I see SQ, I have to replace it. So here, I had SQ of Z, it's gonna replace it with Z times Z. Here, I have SQ of 4.0, it's gonna replace it with 4.0 and 4.0. Now, when my compiler goes through and actually runs my code, this is exactly what it sees. It's already replaced. Macros are almost always defined with all caps. They can and will work without that, but people may not understand that they're a macro. So generally, stylistically, we define them with all caps. The use of parentheses can get confusing, especially if you have a lot of inputs in your macro. So try and limit the use of those, or at least put spaces between them. Again, we don't specify a data type or a return type. There's no data type specification whatsoever with a macro. You'll also notice, and this is really important, the macro does not end in a semicolon. Can you think of why? Think about that for a minute, and we'll get back to an example that shows it. Why would we not use a semicolon at the end? We also don't use an equal sign. Can you think about why? Okay, preprocessor expanded, right? We talked about this. That text just gets replaced by your preprocessor. So your macro will use whatever arguments are there. So let's look at functions versus macros. We're gonna do a square operation done with a function and take a look at what that looks like. So here I have my function prototype. It's declared as a double. SQ is what it's called, and it's expecting one double input called X. Now I go to my main, right? I've declared some variables. I printed it out. Inside my print statement, I have said, hey, run my function with a typecasted z to make sure that's a double. Now, did I need to do that since it was already a float? It would probably work just fine, but just for being thorough, we typecasted it up to a double. Okay, so as soon as it gets to this line and it sees this print, it jumps down and it says, okay, I'm gonna run this function. Whatever is copied in as x, which is z up here, and z has a value of 4.0. So 4.0 is copied into x. I'm gonna return 4.0 times 4.0. That's gonna go back here, then I can print it out. I can see here in j is an integer. I'm gonna run sq of z. So 4.0 again gets passed down. 4.0 times 4.0 gets returned. I typecast that to an int because I know I'm saving it in an int. And then I return 0 and end my function. Okay, so that's everything that has to happen. That's a lot of jumping around for your compiler to have to do for something very, very simple. Okay, so it is more efficient in terms of code space. Every single line is only written once, right? If I have to do multiple square roots, I only have to write one function. But I do have to define the argument and return types, and it here is annoying because I have to typecast them to what I want. So functions are usually more specific than macros are. So let's look again at what that would look like inside of a macro, right? Same exact function. I'm doing the same exact thing, except now I don't have to have a function prototype and I don't have to have a function definition. I don't have to have anything down here. All I'm doing, right, is writing out define, writing my SQ of x, telling it I have one input and I don't, again, have to specify data types, and then telling it what to replace it with. If you remember a couple slides ago, it said we don't use a semicolon and we don't use an equal sign. Why do you think that is? It's because it's just a find and replace. So when this gets replaced, if there was an equal sign here, it would get put in. And you'd have two equal signs and you'd end up getting an error. And it would tell you your error was in this line, when in fact it's in your macro, right up at the very beginning. Same thing with an equal sign. If I were to put an equal sign here, it would just get copied down and you'd have an extra equal sign at the beginning of each of these, and your computer would not understand what's going on. In this case, it'd give you an error, but in this line where it starts with J, it would turn into a conditional. It'd have two equal signs. So we definitely don't want that. So make sure you always double check. No semicolons, no equal signs, just a space. That's part 1 of the functions and macros lecture. We're gonna dive into part 2 next. It will involve why we use macros and what types of macros we actually have and can use in our programs. Again, I'm Professor Casey. Thanks for watching. If you do have any questions, feel free to shoot me an email or leave a comment below. I do check them frequently. Have a great day.